Right, welcome back. Another joyous day of math. Today is a laughably easy lesson. You are going to wonder if you're in the right class because this lesson is so easy. Feel like it should be in a middle school textbook, but it's not. It's in yours. So let's enjoy this really easy lesson. All right, explore. In this course, you might work in groups. Probably not, because we're remote learning. If you don't, you'll likely work in groups in other courses or at your workplace. Knowing yourself and how you work can make working with others more positive and productive. There are two key components to how people work in groups: how they approach problems, and how they communicate. The following activity is designed to help you see what kind of worker you are. So for this, I'm going to be doing my personality and how I approach problems and how I communicate. So your answer might look totally different from mine, and that's okay. So question number 1. This line represents the range of problem-solving approaches from intuitive to logical. And if you don't know what those words mean, intuitive approaches using feelings, so going with your gut, just kind of winging it and doing what feels right. Whereas logical approaches using reasoning and logic. So this might be someone who makes pros and cons lists when making a decision, or reads the instructions when building something. If you're putting together a desk from IKEA, maybe you're going to read the directions. Whereas someone who's intuitive is just going to open the box, throw away the instructions, and go for it. Mark an X to indicate where you fall on this line. So for myself, I said that I was more logical than intuitive, but not totally logical. When I read the instructions, I just kind of skim the pictures, and I don't really make pros and cons lists. If I do, it's in my head. I don't really write them down. So I put my X kind of in the middle, leaning more towards logical. Question number 2. This line represents the range of communication styles from outgoing to reserved. Mark an X to indicate where you fall on this line. I am most of the time an outgoing person. Occasionally, I do get shy and don't really want to talk. So my X is pretty far over on the outgoing part, but not all the way maxed out. Question number 3. We can rearrange the two lines and have them intersect to form a two-dimensional picture. Redraw the X's where you drew that you drew above on the lines shown here. So our X-axis is now the outgoing to reserved communication style. So I'm just going to transfer that X onto the pretty outgoing side there. And then my Y-axis, they flipped that line to go vertically, so not up and down. So my Y-axis from logical to intuitive. And I said that I was mostly logical, but slightly intuitive. And that was number 3. So easy. I hope you guys aren't getting confused at all. Question number 4. Draw a horizontal dashed line through your X on the line for problem-solving style. So horizontal, like the horizon in the sky. There we go. Beautiful. Draw a vertical dashed line through your X on the line for communication style. Oh, fantastic. Why didn't I become an art teacher? I don't know. The point where these dashed lines cross is your position on this graph. Draw a dot at this intersection. It's possible for this point to be on one of the original lines. So it could be on the X or the Y axis, and that's okay. There's nothing wrong with that. So here is my dot. This is how I work with others. Now, knowing how you work with others is important. If we take a look at this orange sticky note here. If you're working in a group, it's ideal if all members contribute and communicate effectively. If a group has too many leaders or followers, think about ways to help the group function better. That could mean asking a group member to give everyone a chance to participate, or it could mean asking someone to participate more. Some notes that the book gives you: if you can't remember what a coordinate plane is, you're going through that graph and you're like, wow, I don't remember the last time I saw one of those. Here are your notes to review. We have our y-axis, our x-axis. They tell you where the positive and negative numbers are. They tell you the quadrants. Quadrants aren't necessarily the most important thing to know in life, but it's a good idea to at least be exposed to them just in case they do pop up later in a college class. So we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. They're represented with Roman numerals. Why? I have really no idea, but they are. Next definition is a variable. They have an example on plotting a point in case you really have a ton of cobwebs up in your brain and you don't remember how to plot a point. They gave you the directions. Example number 2 goes through how to state an ordered pair and find which quadrant or axis a point is located on in case you don't remember that. And then if you really, really, really need more help, they give you step-by-step instructions. And question number 5 is our practice on plotting those points. So I'll go through letter A with you, plotting the point 3, 4. So we're going to start at our origin. We're going to go 3 to the right in the positive direction on the x-axis because 3 is an x and 4 is a y. Positive y, so I'm going to go up 1, 2, 3, 4. And that is point A. It is in the first quadrant. All right. Go ahead, try B through F. Hopefully it takes you no more than 2 seconds to complete. And then question number 6, kind of the opposite, stating the ordered pair and then the quadrant or axis. Let's do point D because it looks like it's right on the axis. So we go over in the x direction, we go to the left 2, so -2 is my x value, and then I go up 0. So 0 is my y value. -2, 0. Oh, wrote that in the wrong spot. Okay. Which quadrant or axis is this point on? Well, it's not in any of the quadrants because it's on a line or on an axis, and it happens to be on the x-axis. Okay, so this point's located on my x-axis. Perfect. Moving on to question number 7. This is our last one, probably the hardest one, even though it's not even that hard, of this section. The following graph from a study on Facebook use is called a scatter plot. Dun, dun, dun. It shows how the amount of time spent on Facebook is related to college GPA. It gives the impression that GPA falls fairly significantly as the number of minutes spent on Facebook increases. So if we're looking at the graph, we see less minutes. Oh, I'm actually going to use a highlighter. There's my first point. We're spending a little over 100 minutes, and our GPA is right above a 3.9. And then we go all the way down to almost 400 minutes, and it looks like that my GPA has dropped significantly. This impression is influenced in part by the scale on the y-axis, which includes a minimum and a maximum value, and the increment, or the difference between the tick marks. The scatter plot shown has a minimum GPA of 2.5 and a maximum of 3.0 with an increment of 0.1. The jagged start on the y-axis, so this guy right here, indicates that the graph starts at a value other than 0. So we're going to redraw the scatter plot with a scale of 0 to 4, and the increments and with an increment of 1 on the y-axis. So my y-axis is going to be our GPA still, but this time I'm going to use increments of 1. So 1, 2, 3, and 4. And then I'll keep the x-axis the same. I'm not changing anything about it. Pretty evenly distributed. So we've got 100, 200, 300, 400, and this was minutes on Facebook daily. And then I'll regraph those points and see how that changes the relationship between GPA and time spent on Facebook. So my first point, let's label it A, B, C, D, and E, just so it's easier for you to know which point I'm talking about, because I can't actually point to it on the board and say I'm talking about this point. So point A, I'll redraw a little over 100 minutes and a little bit above a 3.9 GPA. So that's approximately right here. Kind of hard to graph on my new graph because the increments are larger. Point B is a little over 200 minutes and a 2.85. So a little over that, maybe right here. Point C is a little less than 300 and almost a 2.7 GPA. D is over 300 minutes, a little bit higher GPA. And then E is less than 400 minutes and about a 2.5 GPA. So right here. Now, we need to comment on the impression the new graph gives about the relationship between GPA and time spent on Facebook. Well, if I'm looking at the original graph, the impression that's being influenced here is that your GPA is going to drop significantly with the amount of time spent on Facebook. But if we rearranged our y-axis and increased the increments to 1, it really doesn't look like your GPA is being affected that much by the minutes on Facebook. But if you spend 100 minutes on Facebook versus 400 minutes on Facebook, it really doesn't look like your GPA is changing at all. So when you're looking at a graph in real life, make sure that you're looking at all the information, how the x-axis is scaled, how the y-axis is scaled, and see if it's in any way misleading, because that happens all the time in order to skew the audience's view, making them see the data the way that the presenter is wanting them to see the data, if that makes sense. That's it for today. Like I said, a laughably easy lesson. Should be so quick to finish. I gave you 3 homework problems, just as easy as the ones that we did in the book together. Turn it in as soon as you're done. Have a good one.